For over 50 years, the moon has been a distant memory. Today, it becomes a destination. This is Artemis 2, a 10-day journey aboard the most powerful rocket ever built. These 4 explorers aren't just conducting a flyby, they're building the bridge for Artemis 3, where humanity will finally set foot on the lunar surface once again. Meet the crew of Artemis 2, a team of 4 pioneers selected to carry the dreams of our whole planet. Representing the best of NASA and the Canadian Space Agency, these aren't just elite explorers. They are a symbol of international cooperation, ready to lead humanity's boldest return to the moon. Firstly, Commander Reed Wiseman. He will lead this historic crew, a veteran of the International Space Station, and with his leadership will be the anchor for this first crewed lunar mission of the 21st century. Pilot Victor Glover. He will take the stick of the Orion capsule to navigate into deep space for the journey to the moon. Mission Specialist Christina Cook. She already holds the record for the longest single spaceflight by a woman. On this mission, she is destined to become the first woman to reach the moon. Finally, Mission Specialist Jeremy Hansen. He will make history for Canada. As a colonel in the Royal Canadian Air Force, he will be the first non-American to ever leave Earth's orbit. Artemis 2 won't just be a flight. It will be a high-stakes stress test for our deep space systems. Over 10 days, the crew is scheduled to fly a hybrid free return trajectory. After clearing Earth's orbit, Orion will use a lunar flyby to slingshot around the far side of the moon. They will travel over 230,000 miles away from home, reaching speeds no human has experienced since 1972. The moon's gravity will then naturally pull them back towards Earth for the journey home. 4 flight-proven RS-25 engines will provide 2 million pounds of liquid-fueled thrust to lift the stack off the pad. 2 5-segment solid rocket boosters will provide over 75% of the initial power needed to break Earth's gravity. The Interim Cryogenic Propulsion Stage will provide the kick that sends the Orion capsule out of Earth's orbit and towards the moon. The service module, which was built by the European Space Agency, is the powerhouse that will provide the capsule with air, water, electricity, and vital propulsion. The Orion capsule, which the crew has named Integrity, will serve as the pressurized home for our 4 astronauts throughout their 10-day journey. The launch abort system is the safety tower designed to pull the crew to safety if the rocket fails during ascent. ESA's service module will be the mission's heartbeat. It will use 4 solar wings to track the sun and power the life support systems. Orion is built for the rigors of deep space, featuring advanced radiation shielding and a glass cockpit for manual navigation. The launch abort system will stand ready as the world's most powerful ejection seat, capable of outrunning an explosion in milliseconds. At T+2 minutes and 9 seconds, the boosters will finish their burn and fall away into the Atlantic Ocean. At 3 minutes and 18 seconds, the launch abort system will be discarded as the crew reaches the safety of space. MECO, which stands for Main Engine Cutoff, is the most significant milestone in the entire launch sequence because it marks the moment the SLS Rocket stops being a rocket and the Orion spacecraft becomes more like a satellite. The massive orange core stage will separate, leaving Orion and the ICPS upper stage to drift into a temporary parking orbit. Before heading to the moon, the crew will perform a manual flight test, using the spent ICPS stage as a target to practice future docking maneuvers. This final engine fire near Earth will raise the orbit, perfectly positioning the crew for their moonward slingshot. Orion will enter a high elliptical orbit. Pyrotechnic bolts will fire, cleanly separating the Orion capsule from the stage that carried it into orbit. Using the reaction control thrusters, Orion will perform a 180-degree backflip to face its target for the very first time. Pilot Victor Glover will then take manual control, inching Orion forward until they are just 30 feet away from the rocket stage. The crew will perform delicate lateral maneuvers to ensure Orion handles everything correctly before they commit to deep space. With the proximity test complete, the crew will spend 48 hours in Earth's orbit before Orion breaks away to begin the journey to the moon. The crew will soon be moving at over 20,000 miles per hour as they head into the deep radiation belt. As Earth begins to shrink in the window, Orion will officially become a deep space vessel, traveling further from home than any human in half a century. After traveling 4 days through deep space, Orion will swing behind the moon, where the crew will be cut off from all contact with Earth, while looking out at the mysterious lunar far side. This is a planned communications blackout, lasting between 30 and 50 minutes. Using the moon's gravity as a cosmic slingshot, Orion will begin its fall back to Earth, a journey that will take roughly 4 days of precise navigation. After 10 days in the deep silence of space, the Orion capsule, Integrity, hits the Earth's atmosphere at a blistering 25,000 miles per hour. Outside the windows, the air is turned into a wall of white-hot plasma, reaching 5,000 degrees Fahrenheit. For a few terrifying minutes, the crew is in a total communication blackout for 7 minutes before the parachutes deploy. In the Pacific Ocean, the USS Somerset will stand ready outside of the splash zone area for safety purposes, while Navy divers and recovery teams will be in a closer position waiting for the first sight of Orion's parachutes. Upon splashdown, Orion will hit the water at 20 miles per hour. Navy divers will rush to the capsule to stabilize it and deploy what's called a front porch raft. This precise operation will ensure that the astronauts' first breath of Earth air is a safe one as they prepare to exit the spacecraft. When the crew is safely on board, Artemis 2 will have paved the way for a permanent return to the moon. We will have tested the hardware and challenged its limits. The moon will no longer be just a destination, but will be the beginning of our journey to return to deep space.